Good morning. Today we are looking at chapter 26-2, titled Resistors, in series and in parallel. As the title suggests, resistors can be connected two different ways, in series and in parallel. A resistor in series is when two or more resistors are connected end to end along a single path. A resistor in parallel is a resistor when current from the source splits into two separate branches.
First, let's divide these resistors into parts. As we can see, the 8 ohm resistor and the 4 ohm resistor are connected in parallel. To find this, we use the equation 1 over Req is equal to 1 over resistor plus 1 over resistor. So using this equation, we do 1 over Req is equal to 1 over 8 plus 1 over 4. And that will give us 2.7 ohms. Next, we see the 6 ohm resistor and this one we just found, the 2.7 ohm resistor, are connected in series. Next, we're going to add 6 ohms plus 2.7 ohms to give us 8.7 ohms. Next, we see that the 10 ohm resistor and the 8.7 ohm resistor are connected in parallel. We use the equation for this and we get 4.8 ohms. Lastly, we remain up the remaining resistors, and as we can see, these resistors are connected in series, so we add 4.8 ohms, 5 ohms, and 0.50 ohms to get 10.3 ohms. Once we find the total resistance of the circuit, we can use Ohm's law to find the current passed through this circuit. So Ohm's law states that IR is equal to the total voltage. So since we're given the voltage, which is 9 volts, and we just found the resistor, 10.3 ohms, we can find I, and I will be equal to 9 volts divided by 10.3 ohms, and that gave us an answer of 0.87 amperes.
After calculating how much current is drawn from the battery, we can determine its terminal voltage. Using the equation, voltage is equal to electromagnetic force minus current times resistance. We plug in the values 9 volts minus 0.87 amps found in part B times 0.50 ohms. The resulting answer is 8.6 volts for the terminal voltage of the battery. To find voltage across the 8.7 ohm resistor, we use the same equation from part C, which is voltage is equal to the EMF minus the current times R. Using this equation, we can plug in the numbers 9.0 volts minus 0.87 amps times 0.5 ohms plus 5 ohms. Applying Ohm's law, we get the current and call it I prime. I prime is equal to 9.0 volts minus 0.7 amps times 0.5 ohms plus 5 ohms divided by the 8.7 ohm resistor. This number comes out to be 0.48 amps. Now we have found the current through the 6 ohm resistor, knowing that they are the same between the 8.7 resistor and it.